It's funny. We see it every single day. But have you ever stopped and really truly wondered why the sky is blue? It seems like such a simple question, but the answer is this incredible story, a kind of dance between sunlight, our planet's atmosphere, and even the way our own eyes are built. So let's solve this ancient mystery together. So let's just ask it straight out. Why is the sky blue? Now, you might have heard that it's a reflection of the oceans, or maybe that the air itself is just blue. And those are great guesses, but they're not quite right. The real reason is all about what happens when light from the sun takes an amazing journey to reach us. You see, to figure this out, we're not going to start by looking up at the sky. Nope, we have to start with the source of it all, the light that travels through it. It all starts with the sun, because the sunlight that we see, the light that warms our faces, well, it's hiding a pretty big secret. Okay, this is where our investigation really kicks off, because the light that comes from the sun isn't nearly as simple as it looks. To us, standing down here on Earth, sunlight just looks, well, white, maybe a little yellowish. But that's just a trick our eyes are playing on us. In reality, it's way more colorful than that. Think about when you shine white light through a prism and it splits into a rainbow, right? Well, that's what sunlight is all the time. It's a combination of all the colors of the rainbow, all blended together and traveling as one beam. Now, here's the crucial part. Each of these colors travels as a wave, and they all have different shapes. For this story, you just need to know about two of them. Red light travels in these long, stretched-out waves. But blue light, it travels in short, choppy, high-energy waves. And that difference is the key to absolutely everything. So, we've got our secret rainbow of light. Now let's talk about the second piece of the puzzle. What happens when that light finally gets here and smacks into our planet's atmosphere? Our atmosphere isn't just empty space. It's actually a thick soup of tiny gas molecules, mostly nitrogen and oxygen, with some dust and water floating around too. For the incoming sunlight, it's basically a giant invisible obstacle course. And this whole process of light bumping into these super tiny particles has a name. It's called Rayleigh scattering. It's just a fancy term for what happens when a light wave hits something much, much smaller than itself, which is exactly what's happening when sunlight hits one of those little air molecules. So here's the magic moment. As all those colors of sunlight stream into our atmosphere, the long, lazy red waves just cruise right on past most of those tiny air molecules. But the short, energetic blue waves, they're the perfect size to crash into them constantly, getting bounced around and scattered in every direction, like a pinball. So when you look up, you're not seeing blue air, you're seeing all of that scattered blue light coming at your eyes from all over the sky at once. Okay, but hold on a second. If short waves scatter more easily, and you look at a rainbow, you'll see that violet light has an even shorter wavelength than blue. So shouldn't the sky be violet? I mean, based on the physics, it totally should be. So what gives? And the answer is actually pretty simple. For one thing, the sun just doesn't put out as much violet light as it does blue. But the real clincher is us. Our eyes are just way more sensitive to blue light. So even though the sky is technically a kind of bluish violet, our eyes and our brain basically just pick out the blue and show us the world we're all familiar with. So now that we understand the rules of the game, we can use them to solve another mystery. If the sky is blue all day, why in the world does it turn bright red and orange at sunset? Believe it or not, it's the exact same science at work. The big difference at sunset is the angle. The sun is low on the horizon, so its light has to travel through a much, much thicker slice of the atmosphere to get to where you're standing. It's like the obstacle course just got way, way longer. Because that light has to travel so much farther, almost all of that short wavelength blue light gets scattered away long before it can reach you. It gets completely filtered out. So what's left? The only colors with long enough wavelengths to survive that entire marathon journey are the reds and the oranges. They're the last colors standing, and that's why we get those beautiful sunsets. All right, let's take this idea and really expand our minds a bit. We know how it works here on Earth, but does this apply to other places in the universe? Let's start with a short trip, just outside our own atmosphere. Imagine you're an astronaut floating up there in orbit. If you look away from the sun, what color is the sky? The answer? It's just black. A deep, inky black. Without an atmosphere, there's nothing to scatter the sunlight. There are no particles to bounce the light around. It just travels in a straight line, This is the ultimate proof that our atmosphere is the only thing giving our sky any color at all. And this rule holds true all across the solar system. The color of a planet's sky totally depends on what its atmosphere is made of. On Mars, the atmosphere is full of this fine reddish dust, which scatters light to give it this kind of hazy yellowish-orange sky. And Venus? It's choked with clouds of sulfur dioxide, so its sky is a dark, murky yellow. Each one is like its own cosmic painting, all created by the same laws of physics. So in the end, it really comes down to this perfect combination of things. It's not just the light, it's not just the atmosphere, it's the multicolored nature of sunlight, the specific gases here on Earth, and the unique way our eyes work, all coming together to create the view from our window. So the next time you look up, just remember that you're not actually seeing a blue thing. You're witnessing a beautiful illusion, a constant storm of light and matter playing out across the sky. It's a dance of physics happening trillions of times a second. It really makes you wonder, doesn't it? What other everyday illusions are hiding right in front of us?